Okay, here we are in chapter 5, section 2. We are skipping section 1, so we go right into section 2, and that is adding and subtracting fractions. Yes, this is a little bit of a review for you because you had this in previous grades, but we're going to need this in a couple of chapters. No, next chapter. So that's why we are reviewing it right now, because you will need this next chapter. So hopefully for those who are a little bit rusty, this will help you, but we are going to go quickly through this. So make sure you're ready. You always need your St. James heading, and then you underline and you write chapter 5, section 2, and underline adding and subtracting fractions. Of course, you use a ruler. I can't use a ruler on the smartboard here, but you can. So make sure you're doing that. Okay, we're going to start very simply with some examples just to get us kind of dust the cobwebs and get us back into shape here. If I have 5 over 9, so 5/9 plus 2 over 9, okay, we already have common denominators. Common means these 9s are the same. The denominators are the same. They both have 9s. So I can just add straight across. So I leave the denominator as 9. And then I kind of look at the numerator, and I could even cover the denominator and just treat it as an integer problem. I have 5 plus 2. So 5 plus 2 is 7. So I have 7/9. And that's as simple as it gets, and that's your answer. And we're done. Okay? If the denominators are the same, then all you have to do is add straight across, and you're done. If I have 9/10 and I subtract 1/10, again, the denominators are the same, so I will then leave the denominator alone, and then again use my hand and just cover up the denominator and just look at the numerators, and you're going to get 9 minus 1 is 8. 8 over 10, but that is not simplified, so you need to simplify it and get it into simplest form, and that gives you 4/5. So, and then you want to box that, or make sure you circle it somehow, okay? And that's your answer. Now, of course, we're not always going to have common denominators. That would be boring. So let's try 1/2 plus 1/6. Okay, this is where your least common multiple or your least common denominator will come into play. You want to find the number that's the smallest that both numbers can go into. So we need a denominator that's the same. But you want to use the smallest number just so your life is easier. So your math is easier. And obviously, 2 can go into 6. So I'm going to make the denominators be 6. And 2 times 3 gives you 6. So you have to do 1 times 3. So that's 3. And you leave the other fraction alone. And then when you add straight across, you want to put the denominator down. And again, this becomes an integer problem. 3 plus 1 is 4, 4/6. And then you simplify to being 2/3. 2/3. And you're done. Okay, 2/3 is your answer. You always need a simplest form. Always simplify. Okay, you always simplify. Okay, now let's try some more. So what if I have 5/6 minus 3/8? Okay, again, you want to find the number that both of these denominators go into, because we need common denominators. So for 6 and 8, 24 is an easy one to use. Okay, 6 times 4 gave us 24, so then 5 times 4 is 20. 8 times 3 is 24, so then 3 times 3 is 9. So 20 minus 9 gives us what? What does that give us? 11, okay? And you circle it, and you're done, okay? So you have 11 over 24. Again, is it hard? No, you just have to pay attention. It's not hard, it's just a matter of paying attention. Okay, let's try one more. 7/8 plus 3/4. That's not a nice 4. 3 over 4. There we go. Okay, again, common denominators, even adding. You can leave the 7/8 alone because the 4 can become an 8. 2 times by 2 times by 2, so you get 6 over 8. When you add this, here you get 13 over 8. You do not leave an improper fraction in my classroom, obviously, so you may need to make this into a mixed number. So I'm going to make it a 1, and the denominator stays the same. And you'll get what? 1 and 5/8. And you circle it. Okay, always make sure you simplify, make sure you get rid of the improper fractions, okay, and then solve, okay. Last thing I want to show you is if you're given just variables. So if it says, okay, if it says evaluate, okay, evaluate each expression. Okay, evaluate each expression. Evaluate means what? What does evaluate mean? Evaluate means I want an answer. Okay, I want an answer. That's all evaluate means. And I'm going to say A equals 3/4 and B equals 5 over 6. Okay, so now I'm going to say, what is B minus A? What is B minus A? Well, B stands for 5 over 6 minus 3 over 4. Okay, and now we solve. We solve just like we solved before. The smallest denominator, to make our lives easier, will be 12, not 24. You see 6 and 4 and you might think 24, but 12 is actually smaller. Okay, so 6 times 2, that means you do 5 times 2, that's 10. 4 times 3, and then that means 3 times 3 is 9. So 10 minus 9, obviously, is 1 over 12. So it's 1/12. And you circle it, or box it, and you're done. Okay, so when it says evaluate each expression, that's what that means. And I give you A means this, B means that, and then you solve. Okay, not hard, you just have to pay attention and know what you're doing. Okay, problem for next class. Problem. Make sure you're writing these down. This is the last bit of notes you should have. If you don't have them, then they're not complete. So using the same things as above, what is B minus 7 over 10? And again, B equals what? Equals 5 over 6. Okay? And then solve. I want an answer. Evaluate means I want an answer. Okay? See you next class.